Hey, LinkedIn, welcome back to our Summer Security Foundations live stream. For those that don't know me, I'm Keith Wilson, Director of Cybersecurity Education for AttackIQ. I've been doing a couple of these sessions over the last month or so. I think we've been doing these, maybe a couple months, where we've decided to create a learning path just for summer. So it's a short time learning path that we are going to be changing out eventually, right? So we're going to get rid of this learning path eventually, but for now, we wanted to get you a good head start on some of the foundational courses that we have in our program. So these sessions have been really just kind of a quick preview version of the course. Usually I'll do a couple slides from the course. I'll talk about those slides, maybe clear up some confusion that people have around that. I'll also answer any questions that you might have about the training material. Today, we're talking about the Foundations of Breach and Attack Simulation course. And if you haven't taken the course, that's okay. You're going to get a quick preview of it today. I hope you like what you see and you decide to go take it. If you have taken the course, you can, if you have questions for me, you can put that in the chat. So I'll keep an eye. I'll try to keep an eye on chat. So if you see me kind of turn my head off to the side like that, I'm looking at the chat screen to see if anybody has sent anything. But let's go ahead and get started with kind of talking about the course and the material in the course, and see what we can go over and share with you here. So let's talk about threat-informed defense. And I think I even showed this in the last video that we did, or the last live stream that we did. So they kind of break it down into these three pillars of threat-informed defense. You've got cyber threat intelligence analysis. So this is looking for CTI data. This is your intel data that informs everything else, right? Your defensive measures are built around this. Your tests are defined by this. So you have the cyber threat intelligence aspect of it. You have defensive measures. So these are the detection tools, the sensors, SIMs, any sort of preventative tools that you're putting in place based off of the intelligence that you have and the results of your testing. And then there's this testing and evaluation piece. Okay, so the testing and evaluation piece says, like, okay, we put these controls in place based on threat information, based on our cyber threat intelligence. Let's test and behave the way that the adversary behaves based on our cyber threat intelligence to see how good those defensive measures are. You can do this with testing and evaluation. Doesn't necessarily have to be done with breach and attack simulation. Purple teaming sits in here. Any sort of manual testing could sit in here. Now, what BAS does, and we're going to get into this in a little bit, is allow you to scale that, right? Or maybe you don't have that offensive knowledge on your team. You can use a BAS tool that has some built-in tests and evaluations to run for you. Okay, so breach and attack simulation sits in that part of threat-informed defense, and that's what this course is on, right? This course is teaching the foundations of what breach and attack simulation is and what it does. I think this is a good point too to clear up some confusion. AttackIQ, the company, is not an educational company. We don't live and breathe off of AttackIQ Academy. AttackIQ Academy is just a public good that AttackIQ decided to set up. It was a program that they decided to set up to give back to the community. AttackIQ, the company, sells a breach and attack simulation product. So you will hear me kind of reference that a little bit throughout as we talk today, but I'm still going to keep the conversation fairly general. Now, before breach and attack simulation tools existed, there were still plenty of organizations that were trying to implement, or at least partially implement, a threat-informed defense. And the way the work was originally done through purple teaming activities with red and blue teams can still be done. But again, you're going to have the scalability. So what are some of the things that breach and attack simulation can help you with? So red team members, so you got time and or full-time employees, right? So the amount of full-time employees you may have to hire, or the amount of full-time specialized employees that are dedicating their time to low-level tasks, right? So red team members are generally highly skilled individuals. Generally, they more experience. They could garner a higher pay rate. You don't want them spending a ton of time running scripts and building reports, and you want them innovating. You want them creating new types of attacks. You want them to be focused on exploiting and testing your things, as opposed to actually executing those tests, or even the lower level sort of tests, right? I don't need a red team member to run a net command to see if my environment allows it, right? It also allows for coordination and sharing of information between red and blue teams, right? So uh, having a tool that is used by both, right? A breach and attack simulation tool can be used by both the red team and having it execute the exploits for them, and then the blue team can go in there and look at the reporting and see how the tests are being run, how they're being conducted, and what's passing and what's failing. There's also documentation. Now, documentation during manual efforts is often lacking because of the time commitment or lack of resources to document what was done, how it was done, when it was done, and by who. So, using a breach and attack simulation product logs all those steps for you, right? And so they can tell you exactly the steps that were taken. If the tool is transparent in how they do their testing, they should be able to provide you with that documentation of the test did this, some sort of log file of what occurred during the test. Breach and attack simulations also provide a level of safety, right? Because it gives that collaboration between blue and red teams. It also can define the assets within the scope of that. But it also allows you to put some guardrails around a regular penetration test or a red team engagement that could keep production systems safe. Now I'm going to talk about breach and attack simulations use cases later, and we'll talk about how these use cases fit in, and how they relieve some of these burdens, right? How BAS relieves some of these burdens within these use cases. Now, when considering the use of breach and attack simulation tool for your team, there are a few different ways the deployment can be done. And I know this has been confusing for people, but we'll go over it a little bit here. I think it'd be worth it to spend some time on there. So there's agent-based deployments. An agent-based deployment utilizes individual assets in your environment to execute tests, right? So generally, the agent is going to sit on the host that's controlled by the BAS console. So the agent's going to sit on whatever host you're testing. You may even have like cloud-based agents as well. That's possible. Now, the agent executes tests on or from that host and then reports that data back to the BAS server in the success or failure of those tests. Now, agents are flexible because they allow you to deploy quickly and into specific areas of your environment. So if you're deploying agents in your production environment, you'll want to have a good standing of how safe this is from your vendor. The main reason that you would want to test in production is because that's going to give you the most accurate results, right, of what is truthful to your environment. Production isn't always like lab, but I understand that not all tests can necessarily be run in production. That's why we're going to talk about the next deployment in a second. The last piece I want to hit on, and this isn't in the original course because this was something that AttackIQ developed after the original course was already written. And I'm actually working on a rewrite of this course right now to include some of these updates. The AttackIQ Flex platform, so that's a new product that AttackIQ came up with, AttackIQ Flex. The agent for that is a dissolvable agent, right? So it's not something, they call it a dissolvable agent. The way it's a standalone executable, right? So I can, I don't need to install anything. I can send this executable to whoever I need to run the test for me, or I can just run the executable on the machine myself. It'll generate a zip file, send that results back. So there's nothing that gets installed, but it still is an agent that is running the tests on the machine. It's just not there permanently. One of the limitations of agent-based coverage this agent-based deployment can be proper coverage, right? You really have to understand your use cases. You have to understand the different types of working systems in your environment. It may just not be feasible for you to get agents on all these different machines, whether it's because of change control restrictions and internal policy, or it could be something like just cost, right? Like the licensing of an agent just may be too much for you. So you need to figure out how to strategically place those agents. And if you've joined on to these sessions before or taken some of our other courses, one of the metrics I refer to a lot when I talk about threat-informed defense metrics is your confidence score, right? So obviously, the more machines that you can place agents on, the more coverage that you have of the environment, the more confident you are in those results. Now, there's also a virtual-based deployment. And this one really, maybe it's my choice of wording on this, and maybe I'll update that. Virtual-based deployment is simply a deployment that isn't production. Okay. So it involves lab components, and it should be designed to simulate your production network. That's all it is. So it's not necessarily a virtual environment, right? In terms of like, oh, I'm using an OVA or I'm using a virtual computer in that sense. So I get where the confusion comes from. It's virtual in the terms of it's not your production. It is virtually like your production. So maybe I come up with a better term for that. But essentially, this is just having a deployment in a network that, or in an environment that mimics your production network. So it does have some limitations, though. Obviously, the accuracy of your test is going to be different. It's not the same as production. Lab is not production. So you can get it close, and that may be good enough, right? Especially if you're running into policy issues against, being able to deploy this in production. And then there's complexity, right? The complexity of a virtual environment can definitely provide you testing flexibility in the future. But the complexity of virtual-based deployments can often add time and expense to BAS projects, right? So if I've got to create this whole new environment just to run testing in, that's more time and that's more expensive. So that is a downside when you compare it to if you were going to deploy in production. And then there's also services-based deployment. This is really, a lot of the times, this is just a service just conducting tests by simulating or replaying the attacker behavior from a cloud service against a target or a range of targets. A lot of this time, this happens in the public IP space, but can also happen internally as well if there's some use of generally agents to be able to do that. This type of testing is often used as a form of external to internal pen tests, and it's usually focusing on exploitation activities. The deployment for services-based BAS tools is easy because there usually isn't anything to deploy. You sign up for the service, you give them your public IP space, and then they go after that, or you give them your domain name space, and they go for that. So let's talk about the four main approaches to testing BAS tools. So how they execute testing. And again, if you have any questions, go ahead and put it in the comments. I'm going to keep an eye out on that. Let's see. So let's talk about the different types of BAS testing. So behavior emulation is taking specific behaviors of attackers and recreating them as unit tests in the BAS platform. Right. This is generally production safe approach because you're able to focus on specific behaviors instead of payloads. And if you believe a behavior to be a risk to your production network, you can choose other behaviors that may occur before or after the exploitation phase of an attack, right? If I'm concerned about running a test to see if ransomware can be executed in my environment, well, there's generally a couple steps that happen before the ransomware is delivered or executed. Not always, but there are other steps that can happen. So test those other behaviors first. Behavior emulation generally focuses on the pre or post exploitation activities. If your use cases are focused on exploitation activities only, then that could be a limitation to consider. Um, so that's just kind of a way of saying that a lot of the times in a lot of the emulation testing that I've seen, not always, but a lot of the times it's from an assumed breach approach, right? We're not focused so much on initial exploitation. We're focused on the steps that happen before or after and the behaviors that we can look for. Now, behavior replay is generally done by replaying packet captures of actual attacks. It allows you to replicate the actual behavior of an attacker, including actual exploitation. And behavior replay allows for more robust network-based testing. And testing actual behavior with actual exploitation could also be a drawback if you desire to test your production assets, because these tests are a bit harder to make safe. Right, you have to be very certain that the replay that you're playing is safe. Next is malware detonation. So malware detonation is similar to sandboxing, but with a focus on how efficiently your security controls respond instead of understanding how the malware operates. Right, so basically, we're throwing caution in the wind. And we're going to take a known malware sample, execute it in my environment, and see what happens. So obviously, this carries a large risk of impacting the environment if it's run and it's not safe for production. This is something that if you're doing malware detonation, you most likely want to do this in a lab. I would not advocate for doing this in production. And then last, there's services-based testing. And these vary widely depending on the service provider. And they can use a combination of all of these different testing approaches that we've talked about, right? They may even include human elements that analyze or assist in the operation of that test. And because services-based testing can be so different from provider to provider, it's important to have a grasp of what's in scope and out of scope for the testing, and then also how often that testing will be done. So make sure that you understand what your provider is actually testing and how often they're going to do it, what those reports look like what's the actionable information that you're going to get back from these reports. You want to make sure you have an understanding of that with any of these, right? With any sort of BaaS product, you should be looking towards what is the information that I get out of this and what can I do with that information, right? How is this helpful? Now, how transparent the actual tests you're executing, those can also vary from solution to solution. Some BaaS solutions may even take multiple approaches or vary the degree of approach to how transparent they are with their content. So there's a black box approach, and these aren't necessarily industry terms. I mean, I borrowed from like software development and some industry terms to apply to BaaS, but I think they fit, right? A black box approach leaves little visibility to the operator. Um, you you don't necessarily know what's occurring when you execute the tests. You just know that a test is executed. You probably know who the target is, and you may have a general idea of what the test does, but you don't necessarily know for sure, right? This works well for like larger or more experienced organizations that experience difficulty in the lack of detail. I'm sorry, this isn't good for larger or more experienced organizations because there's a lack of detail that's offered in this approach typically. It has limited flexibility of testing. and it's uncomplicated. So this could be good for a less mature security organization that's just looking to get some sort of security control validation project in place, right? This type of approach can also limit red team involvement, leaving their experience out of the validation project. Now, there's a glass box approach, which is a much more open approach than a black box approach. In a glass box approach, operators can view details of how the test is being run. They can get a deeper understanding and, in some cases, make changes to the configuration of how tests are executed. So, an example of this would be a packet capture replay solution. In this case, you're able to see the traffic being used as part of the test, but there's little to no modification available. Now, this is useful for organizations that are larger, more mature, that would like to implement a BAS solution, but may not have the resources or desire to manage the next approach that we're going to talk about. That's the open box approach. And this may become a scalability limit. If your organization does have resources and expertise to achieve more control over how tests are executed, a glass box approach may be somewhat limiting. So let's talk about the last one here, open box. This is where I got a little bit more liberal with the terms. So an open box approach takes the same approach as a glass box approach. However, the source code of the tests are made available to operators. This allows for full transparency and customization of how the tests are executed. An open box approach provides mature security organizations a ton of flexibility. However, this testing approach may be dangerous if the operators don't have that experience necessary to properly write tests and the proper guardrails aren't in place by the BAS tool. So you have tools like, I can't speak to the other ones, but I can speak to AttackIQ, which will allow you to not only look and modify the source code that's run with the test, and it's all for us, it's all in Python, right? But we provide you with a complete library to create your own tests, right? So that's kind of the ultimate flexibility where I can get in at the code level and modify how these tests are being run. So I really only wanted to toss this up on the screen just to show you all of these different use cases for breach and attack simulation, because there are a lot. So I'm gonna explore a couple of them, and it's the same ones that I do in class. I've worked with multiple customers of AttackIQ in these use cases, so I have a pretty good understanding of them. And just my experience and just in the industry, right? And talking to folks who do have a testing program, and of course our sales engineers here at AttackIQ that have experience in these use cases all the time. They're running these in the field. So let's talk about continuous security validation. Now, this is the process of taking your existing controls, creating unit tests for those controls, then executing those tests and analyzing the result. So if you have a DLP solution or a firewall, and you're using it to block a specific rule or action, for every rule or action you create, you could also design a test for that, right? So I'm going to go, this is the example I use in every course just because it's the most basic version of continuous security validation. So we're going to stick with a firewall example with a blocked URL, and we'll call it www.blockme.com. So once my rule has been created and the policy has been pushed to block www.blockme.com on the firewall, I create a test using a BAS tool or even scripting to try and make that connection from my network through the firewall and out to blockme.com. So I'll execute that test on the red side here, right? So here's my test. First one is to see if I can connect to Google. Next one sees if I can go to blockme.com because that's my new test. So now I execute the test and I make sure that the results come back that it could not connect, because that's what I'm expecting, right? My expected results for this is I'm blocking the blockme.com URL. Therefore, if I try and make a connection to that URL, I should not be able to do that. Now, in this case, you'd want to execute the sort of testing against all of the firewalls to validate that the policy you pushed was deployed correctly. Now, once we validated that our test to blockme.com is actually being blocked, then we can schedule this test, if you're using a breach or attack simulation tool, to occur regularly, the continuous part of this, so that it can be certain that the rule that you put in place continues to work as desired. Because what's going to happen with the next policy push, right? If you push out the next policy on the firewall, maybe that accidentally overrides this rule that you just had put in place. What happens if you do an update to the firewall and for some reason that messes with this rule that you put in place? You won't be aware of it because most security controls fail silently. This allows you to be aware that the security control that you set up one way is no longer working the way that you expect it to. So let's talk about user SOC MSSP testing, right? This is another fairly common for BAS tools, is the testing of your security team. Whether that's an internal person, whether that's an MSSP, whether you've got a combination of both. Simulating or emulating this actual attack, you can understand how your team's going to respond. So this can be useful in identifying gaps in policy, procedure, or training. Now, when designing assessments for personnel testing, it's important to consider a design that would emulate that of an attacker. So using tools like the MITRE ATT&CK Navigator can allow you to see the TTPs known to be used by advanced threat groups. We have so many courses that we teach on the attack framework, and we have a handful that we teach on cyber threat intelligence, actually getting ready to release one here in the next couple days, hopefully, on cyber threat intelligence. So check that out when it comes out. But you want to, if we're working in terms of threat-informed defense, we want to make sure that the tests that we're doing emulate those that are threats that behave like the threats that we face, right? Can be used to help with purple teaming. So breach and attack simulation tools can help with red team execution by providing a platform to make sure test procedures are safe, controlled, and documented. Integrations with other defensive security tools like EDRs, firewalls, AV, IDS, IPS, that can allow your BAS tools to provide the instant feedback in a centralized manner to the red team, right? Did this work? We'll find out real quick, execute the test, see what our integration comes back with to our firewall or our EDR to see what it picked up. Did it detect it? Did it detect anything? Now, those same integrations can provide instant feedback and centralization for the blue team members as well. Some BAS platforms will also provide mitigation information to the blue team to help with that. And if they don't, you can look to MITRE Defend is another really good source, and that's D3FEND. It's another really good source for understanding mitigations. Now, if you missed last week's purple teaming chat, go back and take the Foundations of Purple Teaming course, and you may catch on to some of the terms that I'm going to use here. But during a joint debrief, data collected by the BAS tool can be analyzed by both the blue and red team members. And this data can be used as suggestions for both sides on the next piece, which is continuous testing and improvement, right? Remember, continuous testing and improvement is part of the purple teaming process. And breach and attack simulation tools allow you to begin automating many of the low-level tasks the red team is doing so that they can continue to innovate. Blue teams are also provided with a way to run those lower level red team tasks themselves to validate that the measures taken to resolve red team discoveries are always working, right? So this allows blue team to continue, say we do a purple teaming exercise where we identify all of these gaps. This allows our blue team to put a solution in place, run those same tests again to verify that the solution actually solved the problem. And there's also quality assurance testing. So testing your golden images with the BAS tool can greatly decrease the risk of deploying new workstations with improper configuration. And there's a few things to keep in mind. You want to design your tests to match the security controls you put on the host. Don't just focus on security tool testing. Consider testing operating system policy and other native controls. Utilize a BAS tool with RBAC features that can allow desktop QA engineers to execute testing without having access to results for separation of duties. And then utilizing a BAS tool with an API can allow the process of testing to be baked into part of your QA automation process. Now, in a world where we're seeing more and more of these automated deployments of servers, it makes sense that security teams are becoming more and more involved with the quality assurance of those servers. Now, BAS tools allow security teams and server deployment teams to feel confident in the configuration and setup of these new assets. So when you're doing this, don't forget about a threat-informed defense. Keep the tests lightweight and fast, and only test what you've discovered from intel analysis. Utilize a BAS tool with an API to help automate the process and test rapidly. And then using a BAS tool that can integrate with your security stack can help security operations teams pinpoint what failed if a test does not pass. So it helps them quickly identify that. Still looking for your questions. If you have any questions, please put it in comments. I know we're at the 30-minute mark here. I'm going to run through these. We got like 2 more slides here. I'm going to run through these last 2 use cases. Feel free to stick around for those. If not, catch it later. So after you've identified, say I've identified these gaps, right, in my knowledge, and I want to understand how, or I want to understand which vendors can meet these needs. Well, I can take those same tests and use it to test the products that I'm running against, right? So if you're running a bake-off or a proof of concept with multiple vendors, you can make it kind of fair, and it's a repeatable thing too, right? So you can make it fair and say, listen, we are picking somebody that can solve this problem for us. The problem being this test that we failed. We put a mitigation, we were trying to pick the right mitigation for this. We want to understand if your tool can do this. So you just run the exact same tests that you ran to find the gaps. Now, only use the tests that map specifically to the solution you're evaluating. Don't throw the whole gamut at it. Just specifically. You don't want to go crazy, because if you go crazy and throw tons and tons of testing at it, you're going to go way too long in the buying cycle, and you're never going to get a solution in place, right? So be specific. Only take the tests that failed, that address the gaps that you're trying to fill, make and are specific for the product that you're evaluating. If possible, you want to execute in production. Right? Obviously, if you got to do it in a lab, you got to do it in a lab. But if you can do it in production, even better. And use a control. So I take a scientific approach. I always use a control that is an asset that does not have that sort of protection on it, right? So if I'm testing an EDR solution alongside of the 2 or 3 vendors that I'm looking at, I'm also going to have a regular machine that does not have that EDR solution on it that I'm going to test as well as a control, right? Because if the test gets blocked or doesn't work on that control computer, I know that it wasn't the EDR that prevented it. It was the operating system or something else, right? So use a control. And then you can take these tests after you've selected the product and schedule them to run against the product. And now you've got your continuous security validation, right? Okay, so this is the last slide. We haven't had any questions yet, but I am going to go ahead and pause here just for a minute or two. Looking in the comments, see if there's any questions. If you have questions, go ahead and put them in there. If for some reason you come to this stream later, or your question pops into your head later, you can comment then, and I'll try and reply back in the comments. If you have questions for me about the material that maybe you don't want to put in the comments, you can always get a hold of me or Academy in general just by sending an email to academy@attackiq.com. That goes to my team, but any sort of questions that you have for instructors on courses goes right to the instructor. So if you've got questions on foundations, breach, and attack simulation, I'm your guy. You can email academy@attackiq.com, and I'll make sure I answer your questions. So keep an eye out. As I'm kind of just waiting here to see if any questions trickle in here. Keep an eye out for a couple new things that we're releasing in Academy. We just released a new course, Maturing Threat-Informed Defense with METID. It's a great project that the Center for Threat-Informed Defense put out. gives you a pathway to maturing your threat-informed defense program. We teach you all about it in our latest course. Of course, we've got a Foundations of AI Security course. So if you're wondering what all this AI stuff is and how you're going to secure it and trying to understand the challenges that currently exist for AI, we've got a great course on that as well. And then coming out very, very soon, I'm talking days, maybe a week at the most, we've got our Foundations of Cyber Threat Intelligence course that's coming out. So if you don't really understand cyber threat intelligence and you're looking to expand your knowledge on that, keep a lookout on Academy, as we will be going and adding that in very soon. Like, it's getting added as we speak right now, very soon. If you haven't signed up for Academy, do it right now. academy.attackiq.com. Completely free. Every course in our Academy is 100% free. We don't charge you a thing. And we've got over 30 courses in our catalog now. All right. Well, I'm not seeing any questions, so I hope that means that everybody had a good understanding of breach and attack simulation. If not, hopefully the full course will answer your questions. And always, you can email Academy for questions on the course at academy@attackiq.com. This is the last we're doing in this Summer Security Foundation series. It's been great to have you all on, especially those that were able to make it every week. If you enjoyed it, let us know. We may try and do something like this again. We need the feedback. We need to understand from you if it was something that helped. Or if you think maybe there's something better that we can do. Maybe you got an idea for something better. Again, you can email all that to academy@attackiq.com. Thank you, everybody, for tuning in. We're a little over now. I haven't gotten any questions, so that's good. I hope you all have a great rest of your week, and we'll see you around on AttackIQ Academy. Thanks for showing up.